Hi everyone. So in this lecture, we're going to go over the move instruction and other logical instructions available up here, which are move, mask, move, and or XOR, not, and clear. So we'll start with the move one first. First off, I want to go and add a title. Call it PLC training. And I forgot to add a comment, so I'll call it move and my bad. Move and logical instructions. Okay. There we go. I want to insert a rung, move it down here. Oh, shoot. Well, they don't like to do that, so let's move that up here. There we go. Now we have it. Okay. I might have to delete this, so there it is. Okay. All right, now we're ready. So first off, I'm going to go bring a move. As it says, you move from A to B based on what you want to do. Then the next one is mask move. Then we have an AND instruction. Then we have an OR instruction. So I need a couple of more extra rungs down here. So go to user and drop a rung and we can paste a couple. Let's go back to our move. And then we have an OR. Now we have an XOR. Then we have a NOT. And the last one is clear. So, okay, now we have all of them. Then we'll add a bit in front of all these so we can play with it. So what I want to do is go to bit and bring that guy here. Go to B3, click on usage, and there we go. I'm gonna put all these here, and we can go back to 1, 2, then we got 3, then we got 4, then we got 5, and 6. Nope, my bad. 6. Okay. All right, that's what we got. Now, what I want to do is create a source and a destination, and we'll see how the move works. I'm going to play with the integers when we're doing the move, so I'm going to go ahead and add more integers to this element tree. Let's make it 30. We have a bunch of them. So what we want to do is move from this. Oh, well, I picked the wrong one. I want to move from 10 to 20. Okay. Then we'll do a mask. Do the source of N7. For the mask, we'll leave as is. We'll put a X there to destination. Now for the bitwise, we'll do A, B. Actually, let's delete that. My bad. Okay, here's what I want to do. Do an AND between these two and move it to this. Then we are doing bit inclusive or just an OR, as we all know. Then we have bit exclusive OR. The results shows up here, and then we have a NOT, source to destination, and clear. We'll try and clear one of them as we go on. So now I want to make sure that I can compile my project, and we have an error. We missed a mask address, so I need to go fill up something. For the time being, I want to put all zeros for the mask and see if it takes it. I believe I need 16 of them, but yep, that's what I thought. So let's use an N address. It would be a little easier. So I'm going to use that to mask it. There we go. Oh, everything's good now. We should be able to download after. I'm going to go and clear one of the registers. Let's do in 25. just to satisfy the program, and there we go. So now we want to go do a download. Click on OK. Yes. Oh, okay. It didn't like that. Program incompatible. So let's see. Go active, go online. Let's click on this. We should have this guy happy. And there we go. Oh, I think I missed it. Nope, I did not. I was good. Okay, now we can do a download. Yep. And we'll put the program to run mode. And there we go. Now we are in run. So as you can see, there's nothing getting executed here. So I want to go ahead and put 10 and then 7, 10, and we would toggle the bit. We'll toggle it, and there you go. And 720 has the same one now, as you saw it. Now on the mask move, the way it works is it would move all the registers which you have as one. So if I open up the help on it, so you guys can see what it looks like. Here, the way it shows up is if everything's destination is all 0, your source has some information, and then you're masking based on each bit. So what this is doing is it's just going to move the addresses from source to destination, which has a 1. So the first 8 bits of this 16-bit integer would get moved to the destination. The ones which have 0 in the mask address would stay 0. So in our case, if we go and try and put 255, and I want to open up, I also want to show you what 255 looks on the calculator so you guys can see what I'm talking about. Go to programmer, decimal of 255, the first 8 bits are 1, and so if I want to do 32,000, so there you go. If I do something odd, so if we have 32,600, and in our mask, if I do 255 here, so if I go to N719, which would be this guy, and put in 255, so it's got an FF00, so FF, this is the least significant bit, this is the most significant bit, so 0 and 15. And when we run the instruction, we should only have, based on 32,600, I should only have this, this, and this bit on. So we toggle that, and we have 88. Let's confirm what 88 looks like. Keep in mind it's bit 4, 5, and 7. If I do 88, that's what I have, bit 4, 5, and 7. It only moved that. It didn't move anything on the back end of it. So yeah, that's how the mask move instruction works. Now the AND, that's pretty basic. You just AND from A and B and put into D. So we want to try and get some numbers which are more similar. So let's do 100 and 40. 40, that's 28. So on 100, we have bit 3, 6, and 7 on. And on 40, we have only bit 6 on. So we should only have this bit on the destination when we execute the instruction. So if I execute that, toggle the bit, turn it back off, we have 20H, which if I do 20 in hex, it's only bit 6. So that's how the bitwise AND works. Now we'll do the bitwise inclusive OR, or just an OR bit. So here what we want to do is I'll put the same stuff. So we'll do 100, and we'll use the same number so you guys can see what I'm doing. And we'll execute the instruction. We have 6CH here. So let's 6C, not an H, my bad. So here in this case, 6C means either of them would be on. So I want to do 3 calculators so you guys can see better. Okay, and one more. Okay, so first one we have 100, next one we have 40, and if you do an OR of this, 0 is off in both, 1 is off, 2 is on, which is on here, 3 is on here, 4 is off, 5 is on in both, so it's on, and 6 is on here, so it's on, and 7 is off in both, so it's off here. So that's how an OR works out. Now we'll do this one. We'll feed in the same information. You can enter information in hex as well, like I did. If you put an H on the back, it's going to take it in as an hex. So now we toggle this, take it back out. Now we have 4H. So we'll bring our calculators back and see what it did. So same address, and the hex code is 4C. So what this means is it's only going to put the on where it's, what do we have? Yep, 4C. Okay. So it's only going to put the on where it's the only one on in both of them. So this one's OR with this. So I have a 1. Now this one, it's on here and it's off here. So we have a 1. These two, the first one's, the bit 4 is off in both. So it's off. Bit 5 is on in both. So it's off. Bit 6 is on in only one. So it's on. So it's only going to move the bits if it's only on in one of them, not both of them. So it's kind of like opposite of AND. Now we have a NOT. So when we look at the NOT, if I do 255 and toggle the instruction, we have negative 256. So if I go to the calculator, I'm going to show you both so you guys can see. So we have 255. And if I go to decimal and do negative 256, okay. So what it did is, on the hex, well, yeah, that didn't really help. Let me do something else. 58, and we'll run this. Okay. It basically fills up the opposite, turns everything else off. So, oh, they have an option. Let's try it here. So if I do that, decimal of 58, and I want to run it through a NOT, it's a negative 59. So that's what it did. So 58 looks like this in the decimal version, and then it basically makes it 59 when you run a NOT on it. Now clear basically clears the instruction. So if I run the clear, it's going to clear it off in 725. Pretty simple here. So yeah, that's what we have as far as all the move and logical instructions go. We'll go over the file and some other ones in the next lecture. Thank you.